China have just become the first country to bring back samples from the far side of the moon. This is incredible. Hey Space Cats, I'm Dr. Maggie Lou, and in this week's video we're going to talk about exactly why it's such an accomplishment and what we're likely to learn from this new lunar sample. So let's begin. Chinese space agency CNSA's Chang'e 6 successfully returned the first ever samples of lunar soil from the far side of the moon on the 25th of June 2024. Now, this isn't the first time that China's been to the moon, and it's not even their first sample return mission. Chang'e 5, from which Chang'e 6 was based upon, returned lunar samples from the near side of the moon, so the side that always faces Earth, back in 2020. In fact, the mission architecture of Chang'e 6 was built as a copy of and a backup for Chang'e 5. Following the success of Chang'e 5 in 2020, Chang'e 6 was repurposed to target the far side of the moon. We're not short of lunar samples here on Earth. We've done it countless times before. 300 grams from the Soviets, 1.7 kilograms from Chang'e 5, and a whopping 380 kilograms from the Apollo missions. So what is the big deal? Well, everything previous to this, all those other missions, they were easy. They were all samples recovered from the near side of the moon. But this is the first time that any country has been able to collect samples from the far side. Now, the far side is much more mysterious and unexplored compared to the near side. We didn't get a soft landing there until 2019 by CNSA's Chang'e 4 mission, and no one else has done it unless you count the Intuitive Machines Odysseus lander, which clearly was a massive fail. But the far side is the preferred destination for future human colonies, so it's important. Specifically the lunar South Pole, and this is because scientists believe that the permanently shadowed craters on the moon could contain ice and other minerals, which would be vital resources for sustaining life and adventuring across the rest of the solar system. And also, the far side is shielded from Earth's radio emissions, making it a perfect location to build radio telescopes. So scientists are curious to see what these new samples might reveal. However, the far side of the moon presents a completely different and significantly more challenging environment for exploration and sample collection, and this is due to several factors. Firstly is communication. Unlike landing on the near side of the moon, direct communication with Earth is impossible from the far side due to the moon itself blocking those signals. Any mission there would require a relay satellite, so a satellite orbiting around the moon that would be able to relay information back and forth between the lander and the radio dishes here on Earth. CNSA used Chichao too for this, so you can't just send a lander to the far side, you need to build an orbiter too. The far side is also not as smooth as the near side, and this is because the far side has a thicker crust than the near side. This thicker crust made it more difficult for lava to flow and create the smooth maria that we see here on the near side. But it also means that older impact craters remain intact. Navigating the many craters is incredibly difficult, even for an astronaut being able to do it in real time. And we saw this during the first moon landings when Neil Armstrong had to emergency steer Apollo 11 lunar module Eagle to avoid landing in a hazardous area filled with craters and boulders. Landing on the far side and the sample collection and analysis would require sophisticated robotics and automation with minimal human intervention due to the communication delay. In total, about 2 kilograms of lunar material were drilled into and scooped up from Apollo crater in South Pole Aitken Basin on the far side of the moon. The Chang'e 6 ascender then launched off to bring the samples to return to its orbiter. Note that it doesn't launch off directly from the lunar surface, and this is because the moon is incredibly dusty and this dust is super sharp and abrasive. You don't want to be kicking it up and risk damaging the ascender. So you launch from atop of the lander instead. And then the return brought back samples on the 25th of June 2024 to the grasslands of Inner Mongolia. Scientists are eager to find out exactly what is on the far side of the moon and hope to learn why the near and far sides are so different. The far side is dominated by heavily cratered highlands and few maria, which are abundant here on the near side. This may tell us more about how the moon formed and how it evolved. But it's not all about the moon. The sample may also offer clues about the history of the early solar system. And this is because Apollo crater is meant to be one of the oldest craters still there on the moon. Now, I said earlier that Chang'e 5 brought back lunar samples back in 2020, and their results have just been published. Up until now, the most popular hypothesis about the moon's formation is the giant impact theory, which says that the moon was formed from the debris left over after a Mars-sized planet collided with Earth. Early analysis of Apollo samples suggested that the moon was carbon depleted, which supported this theory. However, recently with the Chang'e 5, they discovered a natural graphene on the moon, and this challenges the whole idea. They found few layer graphene on the moon, which suggests that carbon is indigenous, i.e. it didn't come from Earth. It looks like we may be back to square one on how the moon formed. Hopefully, Chang'e's 6th sample return mission will enlighten us even more about the moon and its formation. Anyway, that's all I have time for this week. Thank you to my YouTube Perks members for supporting this video. As usual, if you enjoyed it, please don't forget to leave me a like, share and subscribe.
Hey space cats, fly with me to the stars, faster than light, soaring past Mars, unveiling the cosmos, new worlds to explore.